Hello, this is Renaud from Agilian, and I'm going to talk about the typical deliverables you should ask your product designers if you are working on electromechanical products, okay? And if you want to make sure that this new product can go into manufacturing. This is based on our experience. This is our 6 phases process for bringing a new product from the beginning into mass production. And the first 3 phases are about the new product design. This is what we're going to focus on in this video. And you can see there are gates and there's a certain logic. These are not the same things, okay? And if you work with designers, engineers who are working on the design of your products, you get to be clear about when they should go into phase 2, when they should get into phase 3, when they should be allowed to say, okay, they have completed gates 3, right? They've completed phase 3 before they go into, really these 2 phases are the development and validation of the manufacturing and testing processes, right? Whereas all of this is about the product design. Right, so this is what we're going to focus on in this video, these 3 phases here. And if we zoom out a little bit, look at it in another way, you make more and more samples as you make progress in the different phases. That's why it goes up and to the right. And what we focus on in this video is on the engineering of deciding what product to build, how to build it, confirming that the requirements are met, confirming that everything is all right and the product design can be frozen. And then it goes into more of an operations team and developing and again, validating the process. Okay, we're just going to look at these 3 phases here, right? Now, I want to also look at this first, because if you zoom out and you really have a clear understanding of how the product design itself is done, you can do a much better job managing designers, engineers, etc. Okay, so that's why I kind of emphasize this. There are 2 tracks usually for most products, especially consumer products. Also a lot of medical devices and so on. There's the look and feel. Okay, you want to get look-like prototypes, and then you want to also work functional prototypes, right? Work-like prototypes. And then at one point they come together as look and work like prototypes or engineering prototypes for engineering validation and so on. Okay, and so look and feel, you work with an industrial designer, they prepare mock-ups, digital mock-ups, right? Sketches, mock-ups, etc. Color, material, finish. They work on all these things about how it's supposed to look and feel and so on. Okay, and then maybe another team, maybe the same team prepares some prototypes to really confirm again the form factor, the feel, etc. Okay, and in parallel, maybe sometimes people start with that, maybe comes a bit after, whatever. But very often a lot of this work is done in parallel, but not necessarily by the same people. Maybe it's managed by the same tech lead, but is maybe not the same teams working on that. Okay, and this is about maybe some design, some research kind of work, rough prototypes, and then more refined prototypes. If there's some embedded software, firmware, typically that needs to be integrated with hardware, and then they make some prototypes that combine both to be really functional, etc., etc., all the way again to engineering prototypes. Okay, now that you have this in mind, we can again go back to these 3 phases. So the first one, so we call feasibility study. And I'm going to focus mostly on consumer products, for example, medical devices or other products that are highly regulated, require the team to go more in depth in some of these aspects. Okay, but feasibility study, now you're thinking, okay, what exactly is the product? What are the requirements? So a product requirement document typically, and the engineering team would help refine it, make it more specific, etc., and really do some maybe pros and cons, and maybe some theoretical calculations and a bit of research and so on to help point to the higher difficulties, maybe the assumptions, and then the product manager, okay, should go back again to maybe to the market and see, okay, which features really are important, because we see which ones tend to be more difficult or more risky. Okay, so there's a lot of thinking here. And the typical output is a plan for at least the next 2 phases. Risk analysis, initial risk analysis, let's say, an initial plan also for reliability and for compliance. These things very often are kind of left aside, but it's good to start to think about these things. The design architecture is going to be extremely important before going into the next phase, the prototyping builds, right? If you pick, for example, the wrong chip, then maybe you will spend 3 months spinning your wheels and going nowhere. So really the design architecture, which are the key components, the key technologies, the key materials, this is very, very important. Once you do that, obviously you selected some of the key components, you start to build an initial engineering BOM, bill of material, which is the list of materials that make up the product. At this stage, again, based on unknowns and assumptions and risks, it's good to start to put together a rough proof of concept prototype. Maybe very rough, partly functional, maybe not even that, but you really basically want to use it to address your assumptions and identified risks. And also, it's good to work with an industrial designer at that stage, so they might give some renderings, they might provide color, material, finish, kind of guidelines, and so on and so forth. It's very, very important for the rest. So that's the feasibility study, right? Now let's go into the prototyping iterations, which is our phase 2, what we call phase 2. Basically, all of the deliverables of phase 1 need to be worked further, taken further, right? So initial risk analysis will need to be a bit more beefed up because the designers have had a lot more time, and the people doing sourcing also have had a lot more time to think about things, right? List of issues, etc., compliance plan, reliability plan, etc., all need to be a bit beefed up. That's a very legitimate assumption. And of course, prototyping iterations, right? So you're going to get prototypes in different design iterations. Now, every design iteration comes with its own design files. So you would expect to get the native files here. And you would also expect to have test reports. So it means that a test plan and maybe a checklist need to be developed. And then every prototype needs to be reviewed against that checklist and that test plan. In parallel, the engineering BOM gets more developed, richer, more information. There has to be, in some cases where high risks are identified, some work done on the compliance side, maybe some pre-testing, maybe design reviews, and same thing for reliability. Sometimes requesting for some critical to reliability components, maybe the test reports from suppliers, or maybe doing your own, maybe highly accelerated live test and these types of reliability tests. And there should also be a plan for, okay, how is this part, this custom design part, going to be made? What process and what surface treatment, etc. What about this one? What about this one? There needs to be a plan. Now, all of that goes into engineering validation. So as I mentioned earlier, this is the last 1 or 2 iterations of prototypes. We're getting pretty close to saying, okay, we have nailed the product design and we can go further, but we can freeze the product design. Okay. So all of the deliverables, again, that I mentioned earlier need to be worked on more in the details. And as I mentioned, this is when typically look like and work like prototypes sort of merge into engineering prototypes. So this is part of the deliverables you need to get. And that's where really by that point, a lot of the requirements in the product requirement document, remember that from the very beginning, need to be met. Okay, so there needs to be really like a sort of a checklist and where does it meet the requirement and maybe to what extent, maybe not 100%, but good engineering teams try to set numerical targets here. And maybe design reviews, maybe a design for manufacturing and assembly, kind of review and adjustments. All of this is obviously very good. Maybe tooling, maybe soft tooling, if really the quality level is very high, or maybe it's medical. In some cases, it becomes necessary. Maybe it's going to be very high quantity. Anyway, it does warrant the fabrication of tooling already at that stage. Now, obviously, what is that tooling? Like, what's the design of the tooling? What's maybe the DFM review of the tooling designers and the tool fabrication team? All of that would make sense if tooling is made at this point. And finally, remember, this is really where the engineering team kind of passes the baby over. In many companies, anyway, that's the way it works. They're still involved and they follow up in the back, of course, but they pass to the more of an operations team, right? So things like the test plan and the checklist used on the prototypes and so on needs to be fine-tuned a little bit, okay, to make sure that the team, maybe the quality team, that we start to own that, really understands it. Similarly, the engineers, when they put together the last prototype, maybe they should make a video. This is a very good practice to really show, okay, that's the way we put it together, and that's, you can see exactly how we do and so on. And then the manufacturing team at the same time is thinking, okay, well, here we need maybe an assembly fixture, maybe we need a go-no-go jig here, and we need this and this and this, right? So this is a high level view, okay? Different projects, different products, of course, this will vary, but I'm trying to paint a picture about, at a high level view, this is what you can generally expect when a new product is designed. Okay, I hope that's helpful. Let us know if you have any questions. Thanks.